In this course we are going to talk about platelets aggregation and antiplatelets. We're going to talk about coagulation and anticoagulation drugs. Okay, so first of all, what we are going to treat above all is about hemostasia. Why? Hemostasia, as we know, is a mechanism of defense of the organism to avoid bleeding in case of injury. So, but it is the case that sometimes this mechanism of defense turns into a disease. That is the case, for example, if we have an atherothrombotic event or a venous thrombotic event. First of all, we are going to draw a vessel. We are going to draw a vessel. In that case, it is an artery vessel. Okay, so first of all, we have the inner layer, that is the endothelium. Below this inner layer, below the endothelium, we are going to find some connective tissue, mainly collagen and fibroblasts. Below we are going to find the medium layer, that is mainly smooth muscle cell. This is the smooth muscle. And then finally we are going to find the external layer, again with connective tissue. So when we have a problem, this is an artery, this is an artery vessel, we can find a problem that we, for example, can have an injury. Then we can have an injury, we have a problem here. It doesn't matter whether we have this is because of a trauma, or it can either be because of an atherothrombotic event. I mean, if we have, for example, an atheroma plaque that is placed in here, and because of the shear stress that we have in the endothelium, then this inner layer, the endothelium, breaks. So this layer of connective tissue gets in contact with blood, and then it starts the hemostasia. So once we have this, the body is going to react by performing what is called the primary hemostasia. That will try to form a clot here, a clot. This primary clot we will call primary hemostasia is mainly formed by platelets. And then this clot is enough to avoid the blood to go out of the vessel, but it's very weak. So we need something stronger to stabilize the clot. That's why it will come the secondary hemostasia with the second clot, secondary hemostasia, that for this we will need the coagulation factors. For this we will have that there are, for this secondary hemostasia, we will see that there are two pathways to get it. Then is the extrinsic pathway, and the intrinsic pathway. This one will make like a 5 to 10% of the clot, and this one it will be like a 90 to 95% of the of this clot by the secondary hemostasia. So in the end, this is what the body does when there is bleeding, and also if we have, for example, an atherothrombotic event. Same things occur also in the venous system, but slightly different. Then, for example, we could say that we have a vessel here, a venous vessel. When we have venous insufficiency, then what happens is that we have those venous valves that, because of dilation of the vessel, are not able to contact, so the blood stacks in here, or either advance in a very low velocity. It leads to we will see that there is a balance in the body between prothrombotic and antithrombotic factors, and then with this stacking here, then the prothrombotic ones will win against the antithrombotics, and then also a clot may form. It can also happen in other parts of the body. For example, we have here the left atrium with the left appendix. It happens that when we have atrial fibrillation, the atrium stops contracting properly, and then also the blood stacks in here, and mainly in the left appendix we can also have a clot due to the same thing. So we are going to review, first of all, what is the primary hemostasia, and then the secondary hemostasia, and after that we are going to review some diagnostic tools that we have, and finally all the drugs that we can use as antiplatelets and anticoagulants. Okay, so first of all, what we have, as we have said, is an injury. We are going to begin with the primary hemostasia, so the form of this weak platelet clot. That is the primary hemostasia. I'm going to put in here primary. So everything begins, we say, with an injury. In the injury that we have here, we are going to have two things. We are going to have endothelium damage. This green layer is damaged, and then we are going to have exposed collagen. So we know that the endothelium is an organ that produces several substances. I mean, for example, one substance that produces is a prostaglandin that is called prostaglandin. It is PGI2. This is produced by an enzyme that is called the cyclooxygenase enzyme. Also, the endothelium produces nitric oxide. This nitric oxide is made by the nitric oxide synthetase that is in the endothelium. Those two are vasodilators. It produces other substances like, for example, endothelin. This endothelin is vasoconstrictor. So, there is always a balance in the endothelium between the vasodilation substances and the vasoconstrictor substances. Usually, the ones that we have more are the vasodilation. That's why the vessels are usually well vasodilated. But if the endothelium gets damaged, there is a decrease, a down-regulation of those vasodilator substances, and an increase of the other ones, of the vasoconstrictors. So here we have that a protective measure to avoid bleeding is vasoconstriction due to endothelin. Then, apart from this vasoconstriction, we have that the proper injury, because of a nerve reflex, here we have a nerve reflex. We know that there are some nerve terminals in the vessels that when it gets injured, it produces a reflex that contracts the smooth muscle. So it leads directly also to the production of vasoconstriction. So the first thing that we are going to have after an injury is a vasoconstriction. After that, we know that there is some exposed collagen that we have here in blue. So when it gets contact with the blood, we know that there are some factors that are traveling through the blood. One of them is what is called the von Willebrand factor. This von Willebrand factor gets activated when it gets in contact with this exposed collagen. And then the von Willebrand factors is the one that will allow the platelets to attach to this exposed collagen. Why? Because we have a platelet here. We are going to draw a platelet. They are not a square, but for the purpose of this lesson, we are going to put in a square, is easier. Then the platelet have several receptors. Some of them are what is called the GP1B. This is the GP1B, the glycoprotein 1B in the platelets. When it can get in contact and attach to the von Willebrand factor that is already attached to the exposed collagen. So it will be the first phase of the primary hemostasia that is called the adhesion. The adhesion, that is the first phase of the primary hemostasis. So here we have the platelets. The platelets have inside some granules that store several substances. Here we have, for example, the alpha granules, and also we have the dense granules. So when the von Willebrand factors joins the GP1B, then the platelet get activated. So here we have the platelet. And here it comes the second phase of the primary hemostasia. There is the platelet activation. When the platelet activation happens, then the platelet starts to releasing the substances that have inside the granules. So, what do we have inside the alpha granules? Well, we are going to find that it will release fibrinogen, this fibrinogen, we will see that is very useful for the platelet aggregation and also for the secondary hemostasia. Also, inside the alpha granules, we will also find this more von Willebrand factor. We already know that it's very useful for this platelet adhesion, but also will help in the secondary hemostasia later. What do we have inside these dense granules? Well, we are going to find calcium. We've seen that this calcium, we are going to see that it is very important also for the secondary hemostasia. We will see later why. We are going to find also serotonin. Serotonin is mainly a vasoconstrictor. So we are going to find that we are going to have more vasoconstrictor substances here. And finally, ADP. ADP, we will see in a minute, that is very important for the next phase of the primary hemostasia. But before, we are going to see another thing, and is that inside the platelet, we also have this cyclooxygenase enzyme, the COX, that in that case, it will transform the phospholipids of the membrane, in that case it's not going to be a vasodilator substance. In that case, we will have thromboxane. This thromboxane will also be released, and it is also a vasoconstrictor substance. This thromboxane also not only produce vasoconstriction, but also contributes because favors the addition, the activation, and also the next phase, that is the aggregation. So we have seen that another substance was ADP, and ADP is very important. Why? Because we have that there are in the platelets, we have some receptors that are called the P2Y12. This P2Y12, when the ADP joins this P2Y12 here, then activates another receptor of the platelets that we have here. This other receptor that are called the GP, that's glycoprotein 2B3A. This glycoprotein that is usually inactive, when we activate this P2Y12, then activates this GP2B3A. And it happens that this ADP and the other substances will not only act in this platelet, but will also act in other platelets that are coming to the same side by blood flow. So this will happen that here we are going to find another P2Y12 receptor, and this will join and then will activate another GP2B3A. So, and what happens now is that the fibrinogen that we have released in here gets in the middle of those two GP glycoproteins. Here it leads to the third phase. That is the third phase that is called the platelet aggregation, because it's allowed to join one and another platelet. That is the third phase. That is the platelet aggregation. And here, due to the platelet aggregation, there will come more and more platelets, and then, so we will be able to produce the clot, that is this clot by the primary.